Yes, today our agenda is that we're going to talk about tree models and then look at the 422, review, and preview. Let's jump in. Our learning target is that you'll be able to use complex tree diagrams and also determine when it is best to use a tree diagram or something else. Let's jump in. My first example, you have blue or gray pants to choose from. So that's our first split in our tree, is that we choose blue or gray pants. Next, you have 3 different shirts. I'm going to label them 1, 2, and 3. And you could either do a blue shirt with the 1, 2, or 3 shirt, or the gray pants with the 1, 2, or 3 shirt. And lastly, you have 2 different hoodies to choose from. So hoodie 1 or hoodie 2, hoodie 1 or 2. You get the idea here. So let me fill in the rest of my tree diagram. This is basically how it gets set up. And lastly, I want to know how many different outfits there are. So I can count them on the far right. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different outfits. So what I want you to notice is that there were 2 pants, 3 different shirts, and 2 different hoodies. And if you multiply these, you get the same number out. Let's try one with a spinner and coins next. So use a spinner with 4 sections and a coin with 2 sides. So I could either get a 1, 2, 3, or 4 on the spinner. And I can either get heads or tails on each of the sides of the coin. So it shows me I've got 2, 4, 6, 8 different possibilities, which again is 4 times 2. Now this tree model works for both of these. Let's try something a little bit more complicated, like this mouse and his race. So it says Ryan has a pet rat, Romeo, and he boasts that he's the smartest rat in the county. Sammy overheard that, and he wants him to run a particular maze to find the cheese. Let's build a tree diagram to show the rats track through the maze. So I notice he's got 1, 2, 3 different initial routes. So I'm going to map those out, 1, 2, or 3. And then the cheese is in chamber A. So here's the cheese. So let's see, from 1, he either gets to B or B or A. B or B or A. So B, no cheese, cheese A. If he takes path 2, he goes straight to the cheese. And if he takes path 3, he either goes to the cheese A or not the cheese B. So A or B. See how this one looks different, where it's not the same and symmetrical. In this case, there's 1, 2, 3, 4, 5, 6 options. And in 1, 2, 3 of them, he gets the cheese, so half the time. How many times will he reach it out of 100 if he's equally likely to choose any path? Well, that'd be 50 times he would win. So I don't think his rat's very smart. I think he just has good chances. Let's look at one more, and then we'll wrap it up for today. In this last example, I've got these 2 spinners, so spinners again, where there's I, U, or A, and spinner 2, there's T or F. Now, notice, here's a tree diagram already drawn for us. Usually it looks kind of like this, so you can kind of imagine I used some PowerPoint skills there. So let's see here. Does this tree model work for these spinners is my question. So take a minute and think about that, because these spinners look different than the first that we had. If you said it does not work, you're on the right track. Reasoning why is because these spinners are not broken up into equal sections. So a tree diagram works best if each section is equally likely. So if each outcome, I'll say. And if it's not, then a tree model is really not the best. On Monday, we'll learn more about area diagrams, so I'm going to pause and kind of wait for that. With the rest of the time we have left in this short video, I'm going to show you what your assignment looks like for today, which is section 422. So here it is. Number 69 is another situation with flipping coins. They flip a penny, a nickel, and a dime, so there'll be a split off for the first penny, and then a nickel, and then dime. You'll have to draw a tree diagram. It's also talking about area model here, but I'd like you to do a tree diagram for this one. The next part is asking you to actually find the probability of any of these cases. Down here, I've got a picture of a triangle, and I want you to draw a flowchart that proves if they're similar or not. Another probability question, and another flowchart question. So kind of go back and forth between those for a bit. Next, there's a couple sequences where it writes out the formula for you, and it wants you to find the first 4 terms. So go back to watch our notes on that from Monday if need be. Lastly, on number 74, there is a tangent problem that you can use to solve for the remaining problems. That's all I've got for today, guys. I hope you have a good weekend, a good rest of your Friday. If you need anything, let me know via email, and I will get back to you by Monday. Thanks.